Hello and welcome. I'm your host, Adam Hawkins. This episode is a small batch of software delivery education. If you enjoy this episode, then share it with your friends and colleagues. This is a special episode of Small Batches. I interviewed Dave Farley in this episode. Dave, along with Jez Humble, is the co-author of Continuous Delivery, originally published in 2010. The book introduced the ideas that eventually grew into DevOps as we know them today. So it's no surprise that DevOps and continuous delivery are effectively synonymous for most people. Together, Dave and Jez introduced continuous delivery to the world. The practices and ideas still hold true 10 years on. Time and research have demonstrated that continuous delivery is the most effective way to develop software. If you've read Accelerate, then you know what I'm talking about. That's partially why I'm so passionate about continuous delivery, and that doesn't even account for the fun I have when working like that. Dave and I talked about different aspects of continuous delivery, beginning with the difference between software development and software engineering, or, as Dave puts it, scientific rationalism. We also speak about the connection between delivery, feedback, and experimentation. Again, as Dave puts it, just doing engineering. He also shared why he doesn't like the term DevOps, and I gotta say, I tend to agree with him after hearing his reasoning. Lastly, I get his view on the pre-flight checks I mentioned in an earlier episode of this podcast. Go to smallbatches.fm/11 to hear that episode. Now, I give you my conversation with Dave Farley. Dave, welcome to the show. So I've already introduced you in my own words. Why don't you introduce yourself in your own words?
Sure. My name is Dave Farley. I'm one of the authors of the Continuous Delivery book. I'm probably best known for that. I am a career software developer. In recent years, I've come to think of myself as a career software engineer. Maybe not, actually. In recent years, I've become a software engineer. I wasn't at the start. So I think I've started to think that one of the reasons why continuous delivery matters is because it's a genuine engineering discipline for software development. And I'm hoping that we're going to talk a little bit about that.
Yeah, so maybe let's start there, because I think from all of us who kind of work in this area, we come at it from different areas. So, I started out as what you'd call kind of just a software developer, right? I was building Rails applications, doing like full stack applications. I built the software, I deployed it, I ran it, and then we have like the segue into like continuous delivery and operations for all the kind of automated stuff you need. But it sounds like you had a different sort of on-ramp here, because you said you didn't really consider yourself, a software engineer initially?
So I started out in the early days of my career with job titles like software engineer. And in the middle part of my career, I worked for companies that didn't like the term engineering and thought it was wrong. And I could understand why that's the case. I think that's often the case for software development. In the latter part of my career, I've done some difficult things and used techniques that I think genuinely count as software engineering. But I think that they're not what we think of. I think that we've got software engineering wrong. And I think that one of the reasons for me that continuous delivery is important as an idea is I think it represents a genuine engineering discipline for software in the sense of applying scientific rationalism to solving problems in software. I think that's the reason why continuous delivery works. And it works better than anything else that we know on the planet. So that's kind of important stuff.
Yeah. So when you say that continuous delivery as like an engineering discipline, are you speaking more towards the technical skills and the context to understand why these are important and to implement? Or like, how do you see this as a discipline sort of different than the other traditional engineering disciplines like back-end engineering or front-end engineering, these type of things?
To my mind, those aren't engineering disciplines because they don't apply scientific rationalism to solving problems in software. They don't use the techniques or the ideas of science. And that's part of the definition of what engineering means in other disciplines. It means applying those sorts of things. What we've come to think of as software engineering isn't engineering by any sensible definition. In other disciplines, when we apply engineering style thinking, we get better outcomes. Engineering is the way in which we amplify the creativity and talents of people to come up with something that's better than those people could do without those disciplines.
I see. So you're kind of taking the hard engineering approach, right? There's this sort of fuzziness when it comes to, quote, software engineering.
Yeah.
Because, most of the time we're just sort of guessing about what we should or shouldn't do.
Yeah, I think there are good reasons why the idea of software craftspersonship if you'll use unpleasant words. But I think there are good ideas why that idea took off, why the idea of craft, is because we are a craft. And the craft is better than what went before. We were trying to turn it into a production line problem before, and that was just dumb. So treating it as a craft is a step forwards. But craft is limited. Craft kind of by definition is limited to the skills and accuracy of individual human beings. Engineering is not. Engineering goes beyond craft and allows us to do things like build iPhones. You can't imagine a craft-built iPhone. It's a crazy idea. So I think that there are techniques in software development that are the equivalent of those sorts of ideas that allow us to do better. And so, I'm a pretty good programmer. I've been a pretty good programmer for several decades, but I can write better software if I apply the disciplines of continuous delivery and other, engineering style approaches to solving problems than if I don't. And we don't have much stuff that's like that. We don't have much stuff that amplifies the talents of individuals who create code. But I think that we've started to recognize a few of those things that genuinely do work in that way. And I think that I am naturally biased, but I think that continuous delivery is one of those kind of things.
I agree. And I think there's like 2 points I want to follow up on about. But the first thing about it just being better is I think there's sort of an anecdotal evidence that all engineers can accept why these are better. Is if you've worked in a system that, say, does not follow the continuous delivery practices versus that one that does, I think there's a clear bias towards which one of these you prefer to work in.
Yeah.
And that to me kind of says the whole thing, right? Especially if you've worked in systems that don't have tests or they do, deploys are automated versus when they're not. Like we as engineers, we have a clear preference for which ways of working are better for us, right? And the other point is I like the focus on, how did you describe it, to engineering rationality or scientific rationality? What did you say?
So I said scientific rationality. Applying scientifically rational thinking to practical problems is, I think, a decent definition of engineering.
Yes, that to me sort of connects to the third way of DevOps of continuous learning and experimentation.
Yes.
Right? Like if you can get your cycle times fast enough and think of, say, your individual changes as hypotheses waiting to be proven or refuted.
Yeah.
Then if you take that rigorous approach, you can make really strong improvements to your product, improvement to your processes, all validated by empirical data. You don't have to guess, right? And that's totally why I see it.
Precisely. Yes. Part of the reason why this is kind of at the forefront of my mind is that I'm in the midst of writing a book on this topic about kind of, what modern software engineering ought to be. And I think you hit the nail on the head, I think, in that software development is almost entirely about exploration. It's about discovery and a growing understanding, a dawning comprehension of the problem that we're trying to solve and the way in which we should try and solve it. And if that's the case, then we practitioners should become world-class at learning and exploration. And the tools of that are the tools of science. That's how humanity learns best. There's one other dimension, though. There's another dimension, which is so I have a bunch of 5 things that kind of contribute to facilitate your learning. But it's really all about science. It's about ideas like iteration and experimentation, empirical discovery, feedback, those sorts of things. But there's another set of things, because we've also got to work to compartmentalize the problem so it fits inside a human brain. And so there's a whole bunch of other things that seem core to this, which are modularity, separation of concerns, information hiding, those sorts of ideas. I think these 2 different collections of ideas, optimizing to be great at learning and optimizing to be effective at managing complexity, seem to me the building blocks of what our profession should do. And I believe that continuous delivery excels at both of those things. It's deeply iterative. It's hugely feedback-driven. We're able to make evidence-based decisions in the way that you say. So we're able to get great opportunities to learn, both in the narrow technical sense within our deployment pipeline, but also by being able to release more frequently into production and learning whether our ideas land with our users and A/B testing, canary releasing, all those sorts of other things as well come into being able to test. And then there's the managing complexity thing. So for me, my brand of continuous delivery, at the heart of that is extreme programming and test and development and all of that kind of stuff.
Adam here. I'm going to jump in and give some background on extreme programming because I have to admit, I haven't heard this term for quite a long time, and I was surprised that it got brought up in the interview. And I understand that maybe you haven't heard about it or haven't come back to it in quite a long time like me. So I'm not going to try to wing it and just describe extreme programming. Instead, I'll give you the first 2 paragraphs from Wikipedia, which I think does a great job summarizing it. You can see from the summary how this serves as a foundation for continuous delivery. And also bear in mind that extreme programming is pretty old at this point. I mean, the ideas are still valid, but a book chronicling extreme programming was introduced or published in 1999. That's a long time ago. But as we know, the ideas have succeeded and they're still in practice today. So here is extreme programming from Wikipedia. Extreme programming, or XP, is a software development methodology which is intended to improve software quality and responsiveness to changing customer requirements. As a type of agile software development, it advocates for frequent releases and short development cycles, which is intended to improve productivity and introduce checkpoints at which new customer requirements can be adopted. Other elements of extreme programming include programming in pairs or doing extensive code review, unit testing of all code, not programming features until they are actually needed, a flat management structure, code simplicity and clarity, expecting changes in the customer's requirements as time passes and the problem is better understood, and frequent communication with the customer among programmers. The methodology takes its name from the idea that the beneficial elements of traditional software engineering practices are taken to, quote, extreme levels. As an example, code reviews are considered a beneficial practice. Taken to the extreme, code can be reviewed continuously, i.e., the practice of pair programming. All of these things now we sort of take for granted as the basis of what I would consider professional software development. And it's no surprise that Dave bring this up, actually, given that automated testing is at the foundation of continuous delivery. It's one of these things we take for granted now, but it might be worth revisiting. Now, back to the interview.
And when you apply that kind of thinking to software development, you naturally build more modular, more loosely coupled code with better separation of concerns, because that's what testable code looks like. That's what I mean by engineering. You have these kind of general principles where in continuous delivery, we're going to optimize for fast feedback, and that gives us a deterministic machinery around the automation for all of that. So infrastructure as code and deployment pipelines and so on. So you get all this great information. So that allows you to learn quickly. And if you apply the test-driven development thing, you amplify your design talents, you get a better feedback on your design, and it creates a little pressure on us as software developers to create better designs. And so, it works like engineering. It amplifies our talent.
Mm-hmm. Yeah, I mean, it's a force multiplier for organizations also, right? I think this is part of the other aspect of it that we kind of have to push on more, just as the power of continuous delivery, that sure, it's implemented by the engineers, but it accelerates the whole organization, right? And engineers are ultimately building the products or running the services that make or break the businesses. If the engineering team can move at 10x or 50x, 100x, whatever, that has huge ramifications for the businesses, right?
Absolutely. And that's why it's important. I think if you look at the impact of this on software development, it's hard to point to an organization that we think of as kind of leading the way in software development that isn't practicing some flavor of continuous delivery, even in places that you don't expect. And that's not by surprise. That's not by accident. That's because if I were correct for a moment, let's just play the thought experiment. If I was correct and this was an engineering discipline, then we would expect to be able to see the implications of that. We would expect, in other disciplines, if you apply engineering thinking and practice to something, you're going to get a better outcome. And you would expect the same to be true here. And when we measure performance through the State of DevOps report and the Accelerate book and all of that kind of stuff, we see precisely that. But you just look around, Amazon, Google, Netflix, Spotify, Tesla, Capital One Bank, ING Bank, Ericsson, you name it. You point to those organizations that we think of as leaders in the space of information technology. They're doing some flavor of this because that's what works.
Yeah, I think it's almost a prerequisite. Is that I don't think you can be competitive in the market if you aren't. The fact that Tesla started doing over-the-air updates to their car software is effectively some form of continuous delivery, and at least far more than it was before. And now other companies have to do the same thing to remain competitive. So I want to bring the conversation back to your book on continuous delivery, which was, I think, released probably almost 10 years ago now.
It was 10 years ago last week.
Oh, well, congratulations on the 10th year anniversary.
Yeah, thank you.
So how do you feel about the relevance of the book, like when it was written as it was today? And, how do you see the adoption of these practices in the industry now?
So in terms of the relevance of the book, I'm proud of the way it stood up. I think the ideas have stood the test of time pretty well. Some of the examples are probably a little bit dated. I certainly can remember writing a few Ant script examples, stuff like that. There's not too many people using Ant for their deployments anymore. So there's that kind of dating. But I think that it was always a book of ideas rather than press this button and expect this result kind of thing. And I think those ideas have stood quite strongly the test of time. And I think that, going back to my earlier point, if this was genuine engineering, we would expect those ideas to be durable. The principal foundational ideas of engineering in a discipline don't change. The way, the things that you apply them to and so on might. The artifacts that we create through these principles might change. But it's like we were talking about before about, managing the complexity. Modularity doesn't go out of fashion. I learned to program over 40 years ago, and modularity was a big deal then too. It still is, and that stuff is important. So I'm proud of the level, the way that continuous delivery is still relevant, and from a purely practical point of view, it's quite nice that it's still selling as well.
Yeah, I mean, I think that really the ideas have been vindicated, especially now with the data that we have from the State of DevOps and the work by Gene Kim and all of those people on Accelerate. Now we can see that there's a clear correlation between working in this way and the business outcomes. And now, all maybe not all, but there's certainly a larger mental presence of these practices than there were, X number of years ago. I think you said somewhere that you happened to have the first DevOps book before there was DevOps. Continuous delivery is the principle of flow. But now, like earlier in the conversation, I'm curious, I don't remember, or kind of want to get your take on this, is how prevalent was the idea of the scientific rationalism in the original book?
I am a nerd. I'm a technologist and a hardcore kind of nerdy person. It's just the nature of the beast, and I've always been fascinated by science and engineering. So that was kind of probably in the back of my mind when I was thinking about it, and has always some degree influenced the way that I approach work. But that I wasn't as philosophical about this then when we wrote the book as I am now. The continuous delivery book evolved completely empirically. We were doing a lot of projects. We were pushing the boundaries. We were working in an organization that was, I'd been a very early adopter of extreme programming and using those sorts of techniques. And I was working in an organization that was kind of scaling that up and doing it in bigger organizations and interestingly challenging places. So we were trying lots of stuff out. And so we got lots of things wrong. We learnt lots of lessons by screwing up in lots of interesting ways. And so the continuous delivery practices kind of got born out of that. So it was really sort of seeing how these things came out and then trying to refine them into structured picture. And certainly when Jez and I wrote the book, we were kind of nervous about claiming a methodology. We kind of looked at it and we thought, this looks like a complete software approach. But we were nervous of saying that in the book because we thought that it would be claiming too much. So we didn't. So we kind of focused primarily on the technical aspect, which are interesting, but not enough. And as a result, I think, if the book had been twice as big and we covered all of those other things, we probably could have written, a complete Bible that told the whole story. But I think we kind of had that in our grasp. We didn't have the nerve to go for it. So now I'm a bit more relaxed about it because it's been demonstrated and we've got much more evidence, and so I can feel much happier now to say this is a way of organising our thinking to do a better job of software development. You mentioned the DevOps term, which is I love the ideas, I love the principles, I love the people that do it, and hate the term.
Oh, really?
Yeah, because I think it's misleading. So either it's too narrow, it's about the relationship between dev and ops, which is very important but not enough, or it's too broad, in which case what you're really talking about is continuous delivery, not DevOps.
I can see that, because there's so much more to like the overall outcome that we're trying to achieve by these practices by then just saying combining dev and ops, right? Because it's really I think it's just more than an engineering thing. It's an organizational way of organizing also.
So I make a living these days as a consultant, advising organizations around the world on how to improve their software engineering practices, is the way that I think about it now, but completely in the context of continuous delivery. And the way that I talk to my clients is, if you want to become good at this stuff, you've got to address technical performance, organizational performance, and cultural performance. You can't do any one of those and succeed.
Yeah, that's where the challenge is, right?
It is. Yeah. So I can explain the value and the impact of continuous delivery, in a few tens of minutes, maybe an hour, and kind of do a reasonably good sales pitch. The trouble is, it's bloody hard to do. It's radically different, and it takes a huge change in emphasis and approach to do this, and that requires using organizations as a tool. You shape the organizations to deliver the outcome that you want. It requires you to change the culture, the way in which you approach development, testing, operations. All of those things are, product ownership. All of those things are impacted by this idea. And then there's the technicalities of automating as much of your process as you can to kind of liberate human creativity. It's a difficult thing to do well, certainly at scale.
Well, nothing that's easy is worth doing, right? It's the hard things that make the real difference.
Indeed.
One of the challenges that I've seen in implementing continuous delivery in organizations is striking the balance between the technical skills required to achieve these things, like being sufficiently skilled in the various automation tools to build deployment pipelines, actually work with them, work effectively at a high enough level of TDD where you can get that fast feedback cycle going. Then you add all these sort of lower level engineering practices on top or maybe below the actual, like the feature work, the bug fix and all this stuff. And then maybe people in the team just have never considered like making a deployment pipeline, considered, working and writing like automated stuff, let alone like working with infrastructure, like running it themselves, like these type of things. So, and of course there's the desire to keep the teams like small and autonomous, like they can fit everything that they need to be responsible for inside their team. But in order for us to achieve this software, like continuous delivery skill or engineering discipline, how do you balance this sort of much larger technical scope that people need to be responsible for with the other, like the kind of feature work that engineers just have to do on a day-to-day basis?
Yeah, I confess I struggle a little with answering this question, in part because the culture that I come from doesn't suffer the problem that you're describing.
Oh, lucky.
So what do I mean by that? I am closer to the end of my career than to the beginning of my career. The politest way that I can say that I'm an old dude. When I started out, there weren't lots of tools that just solved the problem. You did a lot of stuff yourself. So that was kind of natural. That was kind of how I learned to deal with computers. The computers were simpler in many ways. And so, incrementally, so it didn't seem to change. So just learning new tools as they came along and adopting them or not is just part of the game. It goes back to what I was saying before about, you optimize for learning and you become good at learning, and then adopting a new tool or a new language or that kind of stuff is less of an issue. If you're looking for a kind of push-button solution to continuous delivery, good luck
There's
to
no
you.
such thing.
There's no such thing. You're not going to find that. But I don't mind that software development as a profession, as I see it, is difficult. In fact, that's why I enjoy it. That's what it is. I believe that software development, certainly in some of the sorts of things that I've seen and sort of worked in, it's kind of at the limits of human creativity. This is difficult, challenging stuff. And so we should be smart and applying the right tools and the right kind of thinking to solve those sorts of problems. We shouldn't take those problems lightly. If I can build something that automated, all of the stuff that you need to care about continuous delivery, you probably wouldn't need programmers. Because it would be that sophisticated. This is difficult stuff, but that's part of the game. So I'm kind of split by this, because of course automation and all those sorts of principles are deeply ingrained at the heart of continuous delivery, and that doesn't seem like the hard part to me. That's not even close to the hard part. So most of my experience of implementing continuous delivery, we built the vast majority of tools that we use. And we were doing this mostly in non-cloud environments for one reason or another, but initially because we predated it, and later because I was working in environments. I finished my development career working in low latency trading systems of various kinds, and the cloud is not fast enough for those systems. So we were doing it all from scratch, from bare metal anyway. And so we built nearly all of our own tools as well as building the software. And that didn't seem like a very difficult thing to do.
No, but I think it speaks to kind of the can-do attitude that you need to succeed in this. If you can see that you as a team, or like individually, there's a gap in whatever your tools are, like what you need to get to this outcome that you want, then you should feel confident enough that you can build something to solve this problem for you, and that it will be better that you did than if you didn't. And part of the constant battle that we all have is there's that stuff like that we as engineers know we need to do, and then the pressure from like the product backlogs and the other stuff. It's like challenges. How do you convince the people who are creating this pressure that these two things aren't separate, but they're actually integrated, right? Like they are deeply important together.
I've been having a debate on Twitter this week. I did some videos on my YouTube channel. I went and chose some crap code and then demonstrated refactoring techniques to show how you get it to testability, sort of thing. People were saying things like, but we have to carry on delivering features. And it's like, but this is a way of going. So, and I came to, we came to in the conversation, the reason that I mentioned this is you kind of came to the conclusion that part of this is down to us. It's down to us believing sufficient, by us, I mean software development professionals. It's down to us taking seriously enough the belief that what we're talking about here is the most effective, most efficient way of writing software.
Adam here for an aside on Dave's comment. So I really appreciate Dave mentioning that this is just down to us. This is something that I've tried to iterate to my coworkers in the sense that if you believe, like I do, that continuous delivery is the most effective way to develop software, then when we are not working in that way, then it's down to us to improve our workflows such that we are. It's also down to us to make sure that our coworkers, engineers, product developers, all the different types of people that we interact with in our daily work are aware of these ideas. We can share the value of this way of working, the principles and all these things. But at the end of the day, it's really down to us as the engineers at the bottom of this whole process to work in this way and make sure that our coworkers do as well. And if we have to, then help and educate and learn and teach, whatever it takes. It's really down to us to make sure that these things happen. So I really appreciate Dave making that comment, and it really resonated with me. I just wanted to share that with you, and I hope it does too. Now, back to the interview.
So if this is the most efficient way of writing software, who on earth is paying people to write crap software slower? That's just
dumb. It's
Yeah. So if you want to create better software, the way to go is to go faster and to do that with higher quality. And one of the things that the State of DevOps report explicitly states is that there's no trade-off there between going fast with high quality and the efficiency of delivery. That's not a problem. So we live with this kind of illusion that there's this problem and cutting corners. Oh, I've got to deliver these features next week. And that's a mistake.
Yeah, I think it's funny you bring up the refactoring example, because it's something that I've encountered too in my own work, is that this was something sort of speaks to my own progression in like competency in these areas, right? So like initially writing code and then figuring out, okay, yeah, I'll have to do some refactoring even before like I learned TDD, right? And then you start to learn TDD, like actual TDD, not just like testing, but actually writing the test first and then writing the code. That's the key difference, right? And then getting just familiar with that and then feeling like, okay, yeah, I have the test, I have the code. Now I'll just change it because the tests are there. But then getting used to that just being the default way of working and thinking for every single bit of code they interact with. And like now for me, refactoring, writing code, writing tests, they're not separate in my mind. It's just the day, it's like just that's how the work is done. You can't change how that happens. But I think this is something that like I have encountered, like training junior engineers and helping them grow, which was you have to first gain the confidence to to work in this way before you see the value of it. But if you don't have somebody like kind of helping you and guiding you through like sort of all these progressions, because we're talking about continuous delivery, but at the end of the day, if you don't have automated tests, you can't even come close to continuous delivery. So like when you're if the decision is like, should we do refactoring or not, that speaks to a problem like much lower in the stack, right? If you have to like have a discussion about like, is it worth it to do refactoring, or how do we fit that into our like overall process, then you're just playing a much lower game there on Maslow's hierarchy of needs.
So I had the privilege of working in one of those teams that were just kind of was off the charts in terms of success. We built one of the world's highest performance financial exchanges, and we organized the whole thing on the basis, the principles of continuous delivery from day one. And I have never seen a more efficient and higher quality development organization. We did the things that people dream of, we were going faster than the business needed us to go at one stage.
Well, that must have been nice.
Yeah, they were kind of, starting to be feeling under pressure to come up with new ideas. That's a bit of an exaggeration, but it's not very much of an exaggeration. It was a fantastic place to work. And when I tell people stories of that experience, I'm pretty sure that there are certain people that just won't believe them, because our experiences were so off the charts compared to other people's. We once decided we didn't like the commercial terms with our relational database vendor for a data warehouse, and we swapped it out in the morning. We swapped it for one of the open source ones. We were in production for 13 months and 5 days before the first defect was noticed by a user. These things seem like I'm just making stuff up, but that's stuff that really happens. So many of the assumptions that we make, if we're not applying engineering thinking and discipline to our software, are because of that, not because it's inherent to software development. Bugs are not inherent to software development. You can eliminate all the obvious ones for sure. There will certainly be hard to find ones, but you can eliminate all the obvious ones for sure. And the data says that organizations that practice continuous delivery full on will get close to 2 orders of magnitude reduction of production defects. That's pretty good going.
Oh yeah, I mean, it's funny you mentioned the bugs, because like one thing that I tell people all the time is that if you graph the number of defects over time, there's an asymptote. You can achieve that asymptote, but you have to work in a certain way to continually root out those regressions and design ways into your system that prevent them from even entering the system. Like if you are thinking about it after the fact, you've already lost the battle, because you have to start at the beginning.
Yes, absolutely.
And this is like when I reread the continuous delivery book, and you're talking about the pre-commit hook and these different phases of the deployment pipeline. It's one of these things I see it now and think, well, yes, it's obvious that we should strive to remove defects as early as possible in the whole deployment pipeline. But for many people, that's a new idea. Like they're used to things only happening after, like at the end of these processes. It's like the same thing that now when we think about stuff like information security and like DevSecOps and this kind of stuff that used to happen at the end when the software was written. But now the whole thing is, yeah, you have your deployment pipeline, put it in there, test for it as early as possible and fail fast, as opposed to finding out about this stuff much later in the process.
Yeah, absolutely. As an aside, that's one of the regrets that I have. I don't have very, very many regrets about the book, but when I was in the middle of writing my part of the book, I was working on this, world's highest performance financial exchange. We're making this exchange publicly available on the internet. So we were a regulated environment that was going to be, that had billions of pounds worth of other people's money hosted on a system to the internet. So we took security really seriously, and we were doing all sorts of kind of what we'd think of now as DevSecOps kind of things. And I didn't write about it in the book because I thought it was obvious that that's what we were talking about. And then later on, people came up with, yeah, but what about security? Oh, yeah.
Well, I mean, that's always the problem, right? It's the things that, we think are obvious or not, right? For us, it might be obvious that there's an intrinsic value of testing that cannot be refuted. But for some people, that's not the case, right? The case has to be made that, yes, automated testing is good. And in fact, it improves cycle time.
Yeah. And that's one of the things that makes the DevSecOps report and the Accelerate book so important, because with their concepts of stability and throughput, we have a measuring stick. So we can measure the impact of almost any change. So does it affect stability, the quality of the work that we produce, or does it affect throughput, the efficiency with which we produce that quality of work? And if you make a change, whether it's, say, you organize your stand-ups or the tech that you use to write your microservices, it ought to move the dial on one of those things or the other. Or what's the point of the change? If it's not improving the efficiency or it's not improving the quality, what's the point?
Yeah. When I read the DevOps handbook, I think it was introduced to 4 metrics of software delivery performance. That to me was a real aha moment, because that's something that I had struggled with for a long time, which was how to actually quantify these things that we're trying to do. And then lead time, deployment frequency, MTTR, and change failure rate. My favorite one is the change failure rate, because that speaks to your point about scientific rationalization, which is if you're constructing your changes as experiments, then you should know if your experiment succeeds or not. And over time, your success rate of successful experiments should go up as you learn more and you gain confidence, you become better at predicting. And you have a way to objectively say, is this better or not? Which is a big part of the hard engineering discipline that we in software don't really do very well.
Yeah. They are fantastic tools for making the cultural and organizational changes as well, because if I merge these two teams together or break them apart, does it improve the throughput or stability of the system? These are important things because, if we want to get to be more scientifically rational and make more evidence-based decisions, we need measurement. And an awful lot of measures are the wrong things. People measure things like test coverage and stuff like that, which is inadvisable. If you want to get good behaviors, you can't really game the quality of the work that you produce and the efficiency with which you produce it. Those are pretty close to measuring the stuff that you really, really want. What you really care is, do your users find it valuable? That's the ultimate feedback. You need, and that's hard to measure. But you can do that kind of stuff if you start carrying out A/B testing and so on. But at the technical level, in terms of the efficiency of a development process, stability and throughput are pretty much it, I think. I have several clients that have taken it seriously and are using it as a tool to drive change on large scale, amongst teams. It's very effective.
Have you, by chance, read the Unicorn Project or familiar with the 5 Ideals introduced by Gene Kim?
I haven't read the Unicorn Project yet. I plan to get to it, but I haven't yet.
Hey again, Adam here for another quick aside on the 5 Ideals in the Unicorn Project. If you haven't heard about the Unicorn Project, it's the follow-up book to the Phoenix Project, categorizing the transformation of Parts Unlimited after a horrible production incident. It effectively chronicles the organization adoption of what we would now call DevOps. The Phoenix Project considers it from sort of a management and operational side, where the main character, Bill, discovers the 3 ways of DevOps effectively, guided by his teacher, a kind of crazy guy named Eric. Then the Unicorn Project is the follow-up described from a developer's perspective inside the organization named Maxine, where she uncovers what's kind of called the 5 ideals. The first ideal is locality and simplicity. The second one is focused flow and joy. The third is improvement of the daily work. Fourth is psychological safety. And the fifth is customer focus. So in locality and simplicity, the idea here is that you should be able to work on small and focused changes in a simple way. Developers shouldn't have to know the whole global state of a system. They should be able to make pointed changes in a simple and safe way. The second one, focus, flow, and joy, is effectively kind of continuous delivery, which is also proven to bring out more happier employees. So the third, improvement of the daily work, this connects to kind of the third way of DevOps, but also tangentially the Toyota Kata and the idea that everything that we do can be improved. And if we focus on making that part of our daily routine, that will create a virtuous feedback loop. The fourth one, and this is actually kind of my favorite, is psychological safety. Now, you might be thinking, okay, yeah, what is psychology having to do with this podcast? But the idea here is that if you are working in an unsafe environment, this might be one where you don't trust your coworkers, you don't trust the systems that you work in, you don't trust the processes in place, or you are afraid that whatever small thing you do is going to have huge negative consequences, you're going to feel this sort of cognitive overhead of, hey, is this okay? Should I be doing this? And that's going to be a real imperative to your work. And the last one, customer focus, is, well, what it says on the tin, that the developers are working towards the end user and they can see their contributions, directly, they can see their contributions are making a difference for the end user, be it the customers or internal consumers, whatever, but the idea is that we are working towards the end deliverable of the product. So this is the 5 ideals. Now back to the interview. Well, if you just search like online for the 5 ideals, one of them is psychological safety. And the point of this one is that if engineers they feel safe in the fact that they can make a change and it's not going to, explode the whole world, then they are more likely to make changes and, just do more of them. Continuous delivery is directly related to that to me, because with a sufficiently rigorous deployment pipeline, you can be confident that if the thing passes through the deployment pipeline, that it is effectively free of all known regressions.
Well, my definition of a deployment pipeline is that a deployment pipeline goes from commit to releasable outcome. Whatever you consider to be a releasable outcome, that's the standard. If you have to do any work at the conclusion of the pipeline, it's not really a deployment pipeline. So at the level at which you as an organization, as a company, as a team care about the quality of your stuff before it goes into production, the deployment pipeline asserts to that level. And so you have at least as much confidence as you ever had in the releasing of your software. And what we find when we practice that kind of approach is that you then build on that confidence and you get higher and higher levels of confidence. When we were building our exchange, we could make any change to our entire enterprise system and evaluate that in 57 minutes and know whether our software was releasable or not at the end. We changed the version of the operating system. We'd update the language. I mentioned we changed the relational databases, changed to the software. We rewrote our architecture about 4 times because we were riffing on it to make the system fast. So any of those kinds of changes, and that's the freedom that it gives you. I go back to the stuff that we started talking about. This is why I think this is engineering. It gives you this framework, this experimental platform on which you can evaluate your ideas and your changes, whatever they are.
Yeah. So I want to ask you one more question here before you wrap up, related to some of the material in the continuous delivery book and around the practice of like removing regressions and preventing bugs from entering production. So in the continuous delivery book, you speak to the importance of, I believe you call them smoke tests. One thing that I really like about continuous delivery is that if you think analytically about the work that you're doing, I think you can arrive at these practices simply by intuition. I'll tell you a story about what happened to me in that, I was building, automated deployment pipelines to, once something had been verified, then you press a button to release to production. Occasionally stuff broke because, things were like misconfigured, say, for example, a mismatch between the load balancer and the port, right? So the thing was deployed, but it was not accessible. So then I thought, well, okay, this is unacceptable. There's no reason why this should, continue. And then because it was all manual, right? Somebody would go to the website and see what was up. So then I thought, okay, no, let's just add a test in this whole deployment process that says like, hey, just make an HTTP request to it and see if you get 200 okay. So then that's sort of how I came to the idea of smoke tests. And then they're there in the book, as a critical part of the whole process, right? Then I started thinking about the process a little bit more like deeply, as things that I thought were covered by the overall test suite turned out were not actually covered. And then regressions ended up slipping through to, like staging or production. And like one of these things was, say, like the absence of certain configuration variables, like environment variables or configuration files or like misconfigurations. It just sort of seemed ridiculous to me that we should deploy the software to verify those things. Like we should do the verification before. So I came up with the idea of what I called these pre-flight checks. The idea was anything that is sort of, if we take the 12-factor app model, which is, a release is a combination of code plus config. And one of them is like only known at the deploy time or like right before. So you need to have some way to actually test that this thing is sane before, pushing it forward. So I started calling these things pre-flight checks and doing things like testing for the presence of configuration variables, configuration files. So like, for example, if an application declares say an environment variable like a database URL, then let's just try to connect the database before we actually do deploy, because if that variable is like missing or malformed in some way, that will create an outage. There's no reason why we should ship anything that will produce an outage. I did a podcast episode on this where I talk a little bit more about it, but whenever I introduce people to this idea, they're kind of like, scratching their heads, like, what do you mean? Like, what is this? Like, they've never heard about this idea before. But then I start to add these into the various deployment pipelines and show people like how they can add more what they're for. And then what happened was, they made a PR, it was reviewed, but they changed some code that actually ended up breaking the pre-flight check. And if the thing was not there, it would have created an outage in production. And then it was caught, right? And then they realized, okay, yes, here's the value of these things I didn't see before. So I'm curious, have you encountered this practice in the wild? And if so, what do you call it?
So yes, I have. I've heard it called a few different things, and I think there's another approach as well. So the kind of pre-flight checks, I kind of like the analogy. I'm a hobbyist pilot, so it resonates with me. So when I was talking about smoke tests in the continuous delivery book, that's kind of what I had in mind. What you want to do is that you want to test that will just check that the plumbing's in place, that everything's working together and connected. I've tended to move on to a different approach for the systems that I got involved in after that. The other ways of doing that is that you make the system itself responsible for kind of a self-validating. So you do those pre-flight checks as part of the startup routine of each component of the system, check that it's brought to its dependencies, and so you do that as kind of inbuilt health checks in the system. And I've done that a few times too. The approach that I tend to prefer, if it works, if you can do it, you can't always, is that I'm going to start from the assumption that the configuration of the system that I'm going to build and evaluate throughout my deployment pipeline is the production configuration, or as close to it as I can possibly get. So when I talk about acceptance tests and deploying acceptance tests, one of the values that I see there is that you are forced to deploy the software in a production-like test environment, by which you mean that that it's configured the same way, that it's got the same version of the operating system, and that's configuration managed, and it's got the same version of the database and the same schemas and the same environment variables, and all of those things are automated and version controlled. And you can do a pretty good job of kind of making sure that is pretty deterministic, and therefore you can then evaluate those changes in a test environment before the deployment pipeline. And when you start using cloud technologies and containers and stuff like that, they kind of give you some of that already. You kind of got the configuration of the system built in. You still got to check connections between the pieces, but you can do those sorts of things. So I think that's useful. But I think there are three different patterns there. So there's kind of the pre-flight checks themselves, which you kind of automate. And I think one of the big values of those in very big, complicated systems is the ability to fail fast. There was some stuff that I was writing for the book, and I can't remember whether it made it in, which was about laying down sort of sedimentary layers of changes. So you kind of put the, you put the base layer down, and then the operating system or something, and then a hypervisor on it, or whatever else it is, and you stack up until you get up to the application at the top. And one of the things that I talked about in that stuff that I wrote, and I can't now remember whether it actually made it into the book or not, was when you lay down each layer, you write some of those kind of simple tests, just sanity tests, to say, have you got all the bits that I think you should, and are you working, so that you can fail fast, and so you can you can really quickly home in on why something's not working, rather than waiting till the whole system's up and running and doing something screwy.
Yeah. After I started working on this idea for a while, my relation with the two things kind of changed. The way that I started thinking about it was, each step of this whole pipeline is some kind of unit of work, whatever it's going to do, I don't know. But there's a set of preconditions that have to be true before the work can complete, and then a set of post conditions that should be true after the work completes. Like in my mind, the pre-flight checks verify the preconditions, and the smoke test assert on the post condition. Actually,
some of the very early steps in continuous delivery were based on those sorts of pre-flight checks, where we'd run some really simple scripts that would just go and do kind of an audit of, is this environment ready for me to deploy the software into?
Yeah, it's surprising too how often those things may not be true, like in ways you don't expect also. And then like once it's there and automated, you can really save you a lot.
Yeah. And there's I like Keith Morris's book on infrastructure as code, and it's one of the things that he recommends is preconditions and post conditions for scripting to do exactly what you're talking about.
Well, Dave, it's been a pleasure to talk to you. I really enjoyed our conversation and learned a lot. Is there anything you'd like to leave the listeners with?
Well, thank you for listening, everybody. If you are interested in any of the ideas that we've talked about, you can see more on my YouTube channel, and I also have some online courses that are available for sale. If you go to YouTube and search for continuous delivery, or if you go to courses.cd.training, that's the URL, you'll find my training courses.
Yes, and I think actually you have a new training course coming out soon, right?
Yeah, that's right. It's out this week.
Okay. Well, Dave, thank you so much for talking with me, and hope to talk to you again.
It's a pleasure. It's nice talking to you. Thank you.
That completes this batch. Visit smallbatches.fm to subscribe to the show for free. Would you like a topic covered on the show? Then call +1 833 933 1912 and leave your request in a voicemail. Hope to have you back again for the next episode. So until then, happy shipping. Want to learn more about DevOps without wasting your time? Then sign up for my free email course at freedevopscourse.com. My course combines the best from the DevOps Handbook, Accelerate, and years of software delivery experience. You'll learn the 3 ways of DevOps and the 4 KPIs of software delivery performance. More importantly, I'll show you how to put that theory into practice. That means shipping better software faster. Sign up today at freedevopscourse.com.